This is TempleOS 5-minute random code walkthrough, episode 77, and I'm your host, Terry Davis. And it looks like we are in the compiler. This is some gnarly code. I think it's move. What is it? It is no op. Oh boy. Op equal. So this routine is called by several operators: plus equals, minus equals, divide equals, mul equals. I can't believe I do all those the same way. Okay, so so the first thing, if it's a register variable, that is different from an address. We operate with a stack machine, and there's two arguments: the address of the variable, of the left-hand variable, and the right-hand plus equal value or whatever. So if the left hand is not an address, then it's a register. That's the only other option. So if it's a register variable, local variable, we don't have register globals. So if it's a register local variable, then it it does that code. And otherwise, where were we when we started? We were down here about. Anyway, so this is if it's an address, not a local. Okay, so we're towards the bottom. Okay, I think this is where, I'm pretty sure. Oh, maybe not. Okay, so I'm going to go to the control right. Control. Okay. Oh. So the other half is not where I expected. Okay. So so we have to apply the operation, and then we have to assign the operation. So this is, the first half is applying the operation, and then I guess the rest is assigning it. Maybe it's not what I thought it was. Oh, there's I'm confused. What's this case statement here? So when you call this, you pass the operator as an argument to this function, and if subtract or divide are converted to reverse, that's if in the compiler, one of the things you always encounter is, first of all, you encounter that address versus local variable. That's one thing you encounter. The other thing you encounter is argument 1 first. Almost all the functions have a if for argument 1 first. And argument, basically there are 2 arguments to most operations, and the argument, it might not matter the order. However, if it's on the stack, then the order does matter. So for example, if you're popping one off the stack and then you're popping another one off the stack, well, it turns out that sometimes it will tell you to do argument 1 first, otherwise it's argument 2 first. And that has to do with the stack. That's why that. So if you're new to the compiler, there are two arguments. Each argument has a type, size, register, and displacement. The type has both the size and the type, and then there's the register and the displacement. So there are about 6 types, I think. I don't know, something like that. There's if you have an immediate value, that's just an integer or float, I guess. No, not, I don't know. Or a register, or a displacement off of a register, or an indexed has another register, 2 registers, so the register type is broken down into 2 types, 2 registers, and it also has a scale factor. So anyway, finally, there's RIP relative, and the stack. So if it's coming off the stack, it starts out as a stack machine, but it converts almost all of them to registers or displacements off the base pointer. But sometimes you still get a stack if it's a deep expression. I guess you might. I don't know. So when God picked this, He wanted us to start here. So this is so if the size is 64-bit and its displacement, RIP displacement, or SIB. In other words, if it's not register, what did we just do? We just did okay. So if A1 first, where are we? We're in the second half. I think I should explain what's going on. So the first half it's doing a push if it's, I think that's stacked. That's kind of weird. What are we doing? We're doing push. This is for, why are there so many pushes? That's if it's stack. I guess that's a special case. Floating point constant. Oh, we're doing that? Is this floating? Oh, this is a floating point operation. Oh, no wonder. I was thinking it was the other one. Oh, this is totally different. Okay. So I have to totally change what I was talking about. So there's a conversion for int to float, or float to int. You have 2 arguments, and each argument might be converted, and we handle the conversion here. This is if the type is not float, then we do a convert. These conversions are done as a template. That means I have some assembly code that I just copy paste into. I assemble some code, and then I just copy it into here. A little tiny bit. I can show you that if you want to see. Go to the compiler, and I have assembler. So each one of these chunks is so somewhere in here is a conversion, I do believe. I could be wrong. No, wait a minute. Where is that? I forgot where it is. I guess I hand code it. Part of the conversion takes place in all of the code is generated in the last few passes, and the arguments I thought the conversion was done. I think the conversion is done right here.